Good morning, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Grabowski, and I'll be your host for today. If you've been following along with us all month, you know that we have been diving deep into the issue of climate change. So talking to climate scientists and explorers from all over the world who are out studying, assessing the impacts, but many of them are also looking for solutions and ways that we can mitigate the issues that our planet is facing. Before we go any further, I want to give a huge shout out to Environment and Climate Change Canada and thank them for their support this month in helping to make all of these events possible. And now I think it's time, let's get to our main event. So really excited to be joined by Josh King today. Josh is a research scientist at Environment and Climate Change Canada who studies changes in snow in the Canadian Arctic and around the world. So using planes, satellites, even Twitter, he's developing new methods to measure how much water is stored in snow to better understand its importance. So Josh gets to travel north on many expeditions. The last time we talked to him, he had just returned from a field campaign in the Northwest Territories. So we're excited, Josh, to be hanging out with you today to learn a little bit more about what you've been up to since we chatted last. And of course, we'll turn things over to our classrooms and let them fire away with some questions when the time comes.
Great. Thanks for the introduction, Joe. Sorry about having some problems with the slides this morning, but I'm glad that you'll be able to show them for me. So I'm really excited to talk to everybody today because, as Joe said, I've recently come back from a field campaign. And I've actually come back from another one since. So I'm going to talk a bit about what we did there and the importance of snow. And as I'm talking and we're looking at pictures, I want you to think up some questions about snow or about the Arctic. You can even tell me something interesting that you already know about snow if you like. We'll just start talking about it that way. So I'm ready if you are, Joe.
All right, perfect. So just a reminder, classrooms, this is the time to come up to the front and click on my screen so it's highlighted in white, and I'm going to do it on my own screen as well, so it's locked that way for our YouTube viewers, and the screen share should start now. All right, Josh, just let me know how it's looking and I'll go full screen.
Great, I can see the whole slide. Perfect. All right, good morning, everybody. So today we're going to talk about snow and ice. I'm really excited to talk to you about this because we've recently released at Environment and Climate Change Canada a report on Canada's changing north. And as part of that, snow is a big part of climate change. So I'd like to talk about that and also a little about the work that I do in the Arctic that's related to snow and ice. Next slide, please. So as Joe said, my name's Josh, and I'm a climate scientist at Environment and Climate Change Canada, where I study the Arctic and snow. But when people ask me what I study, I like to tell them about something called the cryosphere. So this might be a new word to some of you. So let's break it down and take a look at what it means so that we can understand it. And if you can press next, Joe. So the first part of that word here, where we see cryosphere, means cold. So I want you to think cold when you think cryosphere. And the second part, if you press again, is the word sphere. So that's probably a word that you've already heard. And I want you to think about something round, like the globe. More specifically, in this case, we're talking about the places on it. So when we combine those two words, the word cryosphere, what does it mean? Well, I study cold places around the world. If you can press again, Joe. So the places I work are often below 0 Celsius or 32 Fahrenheit, so very cold. And we can find snow and ice in all of those places for up to about 9 months of the year. Next slide, please. So this slide here shows a diagram of the different places that I work. So I'm talking to you today from Toronto, Ontario, Canada, down in the sort of bottom right here of Canada. The places that I work have interesting names like Churchill, Inuvik, Alert, and Eureka. So these are all over the Canadian Arctic. The thing that's most common to these places is that they're all really cold in winter. So the map in the background here shows you what the temperatures are like between December and February in different places of Canada. So you can see in the very far north, where it's very dark blue color, the temperatures are very cold, below -20 Celsius. Now, just because some of the map shows that it's really cold where I work, snow is important to a lot of places in Canada. So for example, in the southwest of British Columbia, sort of on the bottom left part of Canada, Where the winters are more mild, snow in the mountains is important for things like, say, skiing or for water. We'll talk a bit about that more later. Next slide, please. They might be wondering, what do these places look like in winter? So here's a picture of me working in a place called Eureka, Nunavut, out on sea ice in the middle of winter. It's really cold. I'm standing out on sea ice. And just about everywhere you can look around me, you see snow and ice. In the Arctic, up to about 80% of our annual precipitation, so water that comes from the sky, falls in the form of snow. So in areas like this, it's a really important part of the environment to study if there's snow quite a bit of the time. The air is also very cold and the wind's really strong. And so it can make it really hard for us to work. And in the picture here, you can see some of that snow blowing along the ground as I'm working on this weather station. Next slide, please. But the weather in the Arctic isn't always bad. So in this picture, you can see an airplane sort of near the top, and we've landed it on the ice near the North Pole. So we've headed quite a bit further than where I was in the last picture, but the weather's nice and sunny and the winds are calm in this photo. So even though we do get some bad weather and it's tough to work, there's also times that it's really fun. I wouldn't want to wear a t-shirt necessarily in this picture, but I really enjoyed making the measurements here. So you can see me, I'm the person that's sort of digging in the snow and taking some measurements behind the plane. Next slide, please. Other times of the year can be really challenging to work because the sun just doesn't come up. We call this polar darkness. In the picture here, you can see me working in the Northwest Territories this past January. And at that time of the year, we experienced something called polar darkness. So at this time of the year, because of the way the Earth's orbit occurs, we don't see the sun come up above the horizon for a couple months. It's completely dark outside, but it's not completely dark outside all the time. You can see some of the sun sort of peeking above the horizon here, but it's dark enough that we often have to use flashlights. So that little bright spot that you sort of see on my head there, that's a flashlight that's helping me to work. Next slide. Okay, so scientists like me have been studying snow using satellites in space for over 70 years now. It's an important work for us to do because snow covers about 40% of the Earth. So even though you might not see it right now where you live, or you might not see it at all, there's still plenty around us in the world. So this animation that you're seeing on the right is showing you how the snow cover changes in North America from the summer to the winter. So in the winter, it comes all the way back to just the Arctic, sort of the middle of that animation. And then in the winter, it expands all the way out, covering all different parts of North America. Now, looking at snow cover over really long periods, we've noticed two things. If you could press next, Joe, for me. Those two things are, we're noticing that in the spring, our snow is starting to melt earlier. So the timing of when the snow starts to come back to just the Arctic is happening much earlier in the year. And also in the winter, we're seeing that snow is not moving as far south. So in general, the Earth is being covered by less and less snow each year. Now, scientists agree that this isn't a good thing and that humans are causing this as part of climate change. So let's talk a bit about why this is important. So if you've ever looked outside and you saw snow or you've seen snow on television, you might have wondered, why is it so bright and white? Well, this is because snow is really good at reflecting the sun's energy. We can sort of think of it as like sunscreen for the Earth. When we have it around, it's reflecting lots of the sun's energy, and that energy goes back into space. So the reason it looks really bright to us is that all that energy and light that's coming from the sun is being reflected backwards. If you could press next, Joe. The word we use to describe this property of snow is called albedo. You can just think of this as a term describing how much energy can be reflected. If you can press next again, please. So we can say that snow has a very high albedo because it reflects lots and lots of the sun's energy. If you could press next, please. But when it's gone or it's not even there, the Earth's color is a bit darker. And because of that, it absorbs more energy and produces heat that we can feel. And we can say that this part, during this time, the albedo is lower because it's absorbing that energy. So if you've ever touched, say, an asphalt road on a hot sunny day, you might have felt this effect where dark surfaces can heat up really quickly in the sun. So thinking of snow as sunscreen for the Earth, we can see why it's an important part of understanding climate change. When it's there, it helps to keep the Earth cool because it's reflecting a lot of the sun's energy. Well, when it's not, the air can get warmer. Unfortunately, when this happens, it can melt more snow, making the problem even worse. So there's a cycle that occurs here. When we have less snow, it can get warmer. When it gets warmer, we can get less snow. If you could press next, Joe. We call this the snow albedo feedback, and this is part of climate change and one of the main things that I'm trying to study. If you could press next. Now we know that snow is an important part of our climate, but it's also very important to animals in the Arctic. So my good friend here in the top right, the polar bear, likes to build its home in the snow, in building dens in the winter. It also uses it to get out onto sea ice to hunt for its food. The animals in the bottom right here are called muskox, and they live in the Arctic, and they need snow cover to protect their food in the winter so that they can dig down and still get to it after keeping it fresh for them. When snow changes, it can affect these animals, making it harder for them to survive. Next, please. Many humans rely on snow as a source of drinking water, so it's really important to us as well. Snow itself is just frozen water. So when it melts, it returns to liquid water, and then it can fill our lakes and rivers. Even in really warm places like, say, California, snow from the mountains is used for drinking when it melts. So it snows in the mountains where it's still cold, that snow melts, and it comes down to people in the valleys. Humans also have been using snow to get around for a long time. So on a snow machine where there's no roads, we sometimes can go on a snowmobile, like in the picture in the bottom right, or even in parts of Canada, we use snow and ice to build roads on lakes. Now we should remember again that just because we don't see snow around us, it's still part of our everyday lives in a lot of cases because it can give us water to drink, it can help power our homes or influence our climate. Next slide, please. Now, we mentioned earlier that we can use satellites to measure snow and ice. Well, about 7 months ago, as an example, NASA launched a new satellite into space called ICESat-2. This satellite can be used to measure things like how much snow has fallen on a glacier or how much of that glacier has melted by sending a laser beam from space to the ground, which helps us to measure the change in distance. So as there's more and more or less and less, that distance will change. Now, orbiting around the Earth in space, we can collect a lot of information about snow and ice. So in the animation on the right here, you can see that satellite going around and around and around the Earth. It can collect the information a lot quicker than any of us could if we were to go out and try to do it ourselves. And by looking at these measurements over really long periods, we can better understand climate change and how it might be influencing humans as well. Next slide, please. Now, to help us figure out what kind of satellites we need or what those satellites might be measuring, we have to do something called field work, where we go to the Arctic and we do tests. A big part of my job is designing field experiments, deciding where and when we collect information about the snow. We often dig down deep in the snow, like in the diagram on the bottom here, and do all sorts of tests. Next slide, please. So a lot of those tools that we use are very special. They have to be designed to not only work hard, they have to be able to work in really cold environments, but they have to be able to work fast. Joe, if you can press once again, I think it'll start the next animation. Okay, maybe that one won't start, but the tools that we're using have been designed to work in really cold environments, and they let us work really fast so that we can keep ourselves warm as well. Two things that they help us to understand, two things that we need to understand, satellites to measure the snow. Okay, next slide. Oh. Sometimes in the winter, if you look outdoors, the snow might look all the same to you, just white and everywhere. one of the instruments that I use a lot to understand snow is a microscope. So you can see me using one of them in the picture here. And if you can press next, Joe. When we do this and we look at snow under the microscope, we can start to see a lot of details that we can't see with just our eyes. Now this might look a lot different, the picture here, of what you would draw a snowflake looking like. But when snow comes from the sky and sits on the ground, it changes a lot depending on the environment. So I will use tools like a microscope to help us understand how those changes are happening and if they're part of climate change and how we can use satellites to measure them. Next slide, please. Now, I'm not sure how many times I've already said it, but the Arctic can be really cold. So you see some pictures here of everybody working in the field. We have a lot of ice on our face. So when we sweat, that sweat just freezes to us because it's so cold. We have to be really careful when we're working in these conditions because we don't want to get too cold or sweat too much. So we have to be very smart about how we're working. And you can see one of my colleagues in the bottom left here kicking his feet, trying to keep them warm. Now the ice doesn't actually hurt us when it's on us, but it sure looks funny. Next slide, please. To keep warm, we have to dress really well. So there's a lot of different equipment that we wear, but it's kind of similar to the things that you would wear at home in terms of the materials for our extreme cold. But one of the most important things that we carry is a survival kit. So we have to be prepared to stay outside overnight, even if the weather is bad. So inside that bag that's on one of my colleagues here are things like food, a sleeping bag, and a heat source. All things that we would need to keep ourselves safe if we had to stay the night. Next slide, please. Now, when we're in the Arctic, we're often very far from cities or houses, so we don't have the usual places to stay that you might find at home. So we bring our house with us. The picture here is where I was staying this winter. So it's out in the tundra in Inuvik, north of Inuvik in the Northwest Territories. We each get our own tent. It's cold, it's not heated at night, but if we stay in our sleeping bags and we make sure that we're well fed before we go to bed, it's pretty comfortable. Some of these tents that we take out with us even have a stove to keep us warm and allow us to cook our food. With all that snow around, the best way for us to travel really long distances is usually on something called a snow machine or a skidoo. So we can ride over the snow with these very quickly and get us where we need to go. The picture that you're looking at here shows 3 of snow machines with some toboggans on the back. So we have a lot of that scientific equipment we have to carry with us. We can put it in those toboggans and pull it with us very quickly. When things are really far away, like in the North Pole, we sometimes have to use planes to get there. Now the plane that you're looking at here has special skis attached to it so that it could land on the snow. You can see in the animation, our pilots are bringing down the aircraft very slowly. We're actually going to land right on the ice. There's no runway here, so we have to work with very skilled people to land. And it's about to touch down, and we're down safe. So to get to these really far places, we sort of have to make our own methods. We have to find a place to land on our own because nothing's prepared for us. But it's really important for us to make these observations because people can't get to them very often, and we need to be able to understand them. Next slide, please. Sometimes when we're in the field, we get visitors. Now, when we're working, we have to make sure that we put our heads up and we look around often. The reason is we don't want any animals to sneak up on us. So in this picture here, you can see a polar bear. We were working in a building in the Arctic, and we looked up and we saw a polar bear. Now, these animals are curious, but we have to be careful to respect them. When we're there, we're working in their territory, and they're curious, but they can also be very dangerous. So in this situation, we were very quick to move away from the bear and make sure that we weren't in danger. We also get visitors like wolves. So you can see one of the wolves here that's actually howling at us. The thing around its neck is a GPS tracker. So another scientist is actually studying this wolf. But when we were out on the sea ice, this wolf came up to us to check us out. It brought 2 of its friends too. We weren't in any danger in this situation, but again, we have to be very careful to respect this wildlife because we are in its environment. So I hope you enjoyed our tour of the Arctic today. Here's a little picture of some of us flying out of camp a couple years ago. I really enjoy working in the Arctic and studying snow. And as part of that, at Environment and Climate Change Canada, we've recently written a report on not only how snow is part of climate change, but a number of different things. So you can check it out at the website we've listed here. And I'm happy to hear any questions you might have now about my field work, about why we study snow, or just hear about how snow is part of your life. Thanks.
All right. Awesome, Josh. Thanks so much. Classrooms, I just want to give you a reminder. If you click on my little screen, my little box at the bottom, the white will come off and it's going to start to move back and forth normally. So you can see Josh in the other classrooms when they're asking questions. But again, Josh, thanks so much for sharing that with us and just how important snow is. After winter that we're just wrapping up here in the Toronto area, it's hard to remember that there is more importance to snow other than just having to shovel your driveway all the time. So
yeah, it can be annoying, but it's an important thing for us to have for sure.
Absolutely. Well, let's get going. Let's meet some classrooms. We have classrooms from actually 3 countries joining us today. So let's start meeting some of them. So let's see. Why don't we start in Milton, Canada, or Ontario? We're going to go to some grade 4-5s with Mr. Noble. Let me get their microphone turned on. There we go. How are we doing, grade 4-5s?
Yep, we can hear you.
All right, who's up?
Any questions? Okay, guys. Aiden, you have a question? Yeah.
What happens when the summer comes? Does the snow melt?
So when the summer comes, does the snow all melt away?
We do have places where not all the snow melts. So there's places like glaciers in the high Arctic and places like Greenland or Devon ice cap in Canada where we have snow all around the year. So while we might have our snow melt, say in Toronto, there are places that do have snow all year round for sure.
Yeah, and then some of those places in the Arctic, like the tundra, where the snow does melt, then there's that really kind of brief period where it's incredibly productive, isn't it? Where lots of food and lots of animals take advantage of that.
That snow is really important for allowing that vegetation to get the nutrients it needs. So even when it is melting, it's an important part of that ecosystem.
All right, very cool. Great question to start us off. Let's see. Let's go to Leamington, Ontario this time. We have some grade 3-4s hanging out with Mrs. Reeb. Let me get their microphone turned on. How are we doing, Leamington?
Good. My name is Sal, and what other animals have you seen?
Thanks for your question. We see lots of animals when we're up there. Even though it's really cold and people don't think there's many animals around, we see quite a few. So when I was up in Inuvik just this past winter, we saw a lot of caribou. Sometimes you hear about them called reindeer as well. The one animal that comes up a lot that's always really interested in us is the red fox. So when we're cooking or when we're doing anything outdoors, we always have small red fox come up to us. They're very curious. They're very small, but they like to hang out around people. Like I showed in my pictures, we see things like muskox quite often. If we were working out on the sea ice, we might see seals come up through the water. There's all kinds of different animals, and these animals live both above the ground, above the snow and below the snow. So if you dig down in the snow, you might find little animals as well. They need it to be a shelter. So a small mouse might not be able to survive at, say, -30 or -40 Fahrenheit. But if it digs down in the snow and it makes its home down there, it's way, way warmer. Usually say 10 to 15, 20 degrees warmer at the bottom of the snow. So when we look outdoors and we see big animals up top, there's also a lot of life underneath the snow.
All right, awesome. Snow is an important habitat as well. Let's see. Actually, before I forget, I want to give a shout out to Mrs. Tibsharani's class in Canada, Ontario. They were going to join us this morning, but an assembly changed their plans, but they're watching later today. So a big shout out to your class. But let's go to Minneapolis, Minnesota. We have some students hanging out with Mrs. Juba. Let me get her microphone turned on. How are we doing, Minneapolis?
How are we doing? We're doing great.
All right. Does anyone have a snow question or an Arctic question?
Yes, so go on up and say your name.
My name.
Oh, stand up a little louder. There you go.
My name is Lily, and
How much water is in the snow?
how much water is in a snowflake?
Thanks for your question,
Yeah.
Lily. Yeah, no, I heard. So you're asking how much water is in just one snowflake? I think that's really hard for me to say even. The snowflake's a really small thing. But what we do is when all those snowflakes come together and they stack up into the snowpack, we can measure it then. So you might think that, this much snow isn't much water, but when you melt it down, it might fill a whole glass. It's always surprising to me how much water can be stored in snow. And you might learn something called density in school. And that's a big part of learning how much water is stored in the snow. Because not only do we need to know how thick the snow is, we need to know how much of there it is in a really small space. When we look at snow, it's a mixture of both air and ice. So if you were to dig down in the snow, it's not just one continuous block of ice. You'll see little grains of snow. And those used to be the snowflakes. So they fall from the sky and they land and they build up in the snowpack. So what we're measuring is what you're describing, a lot of little snowflakes that have fallen on the ground. So it's really hard to get a really accurate measurement of just one snowflake. But if we measure a lot of them, then we can get a really good understanding of them.
All right, cool question. Let's see. Let's take a little trip to Switzerland. We have a few students who are joining us from Leysin with Mrs. Anderson. Let me get their microphone turned on. Let's see if they have a question for us. How are we doing over there? How are we doing, Mrs. Anderson?
Great. It was snowing yesterday.
Do you have a question for us?
Yeah, I think we have a question.
Sure.
Hello, my name is Adrian, and I was wondering why it snowed in late April.
Here, yep. Ah.
Okay, did you get that, Josh? Why, even though spring has started and it's late April, why are we still getting a little bit of snow sometimes?
So the temperatures that you're feeling down at the ground aren't necessarily how cold it is up in the clouds. So even though, say, it's above zero down where you are on the ground, it might be really cold up in the clouds. This is usually even more true if you're at elevation. So if you live in the mountains in Switzerland and not in the valleys, you'll notice as you go up and up and up, it gets colder and colder. So in April, we might feel like it's really warm on the ground, but up in the sky where the individual snowflakes are forming, it might be below zero. So they can still fall down, and maybe they melt when they hit the ground because it's too warm, but it can still snow when it's pretty warm at the ground level for sure.
All right. We're going to go to Mrs. Mrs. Elliott's class. She's got some sixth graders joining us in Dallas. So I don't think they have to worry too much about snow, but let's get their microphone turned on and see how they're doing today. How are we doing, sixth graders?
We're good. We definitely don't have to deal with snow very often. Go, Lachlan.
Hi. What do you think about companies developing ways to make roads lighter or buildings with white roofs to reduce temperatures?
So you're talking about geoengineering. That's not my area of expertise, but the different things that we can do to combat climate change are all very important. So things like designing roads that don't absorb as much energy, that goes back to the concept of albedo that I was just talking about. So where snow is really bright and white and can reflect a lot of the energy from the surface, things like geoengineering are attempting to change the albedo of surfaces like the houses of our roofs or things like the ground. So there are changes that we can make in our day-to-day lives to help improve the situation, and what you're describing is one of them.
All right. Mrs. Philpott's class. Some grade twos hanging out with us. How are we doing today?
What's the average Fahrenheit temperature in the Arctic?
What's the average Fahrenheit temperature of the Arctic? I would be lying to you if I told you a number right off the top of my head. I actually don't know. But if we looked back at one of the slides that I showed, and I'm going to post those slides later so you can look at them with your class, the temperatures during the winter for the Arctic, a lot of those areas could be -20 Celsius. I don't know the exact conversion from the top of my head, but it's very cold in terms of Fahrenheit. So what I'll do is I'll make sure I post those slides so that you can look at that diagram and you can talk with your class about what those temperatures are like.
And then we haven't touched on this yet. Well, I think we did a little bit during your presentation, but those temperatures are starting to change a little bit, aren't they? We're starting to see, you know, especially our polar regions are starting to warm up at twice the rate of kind of the other places on our planet.
That's right, Joe. The climate change report that I put a link to in the end describes those changes. And part of that is this snow albedo feedback that we're also talking about in the presentation, where we get warmer temperatures, there's less snow because it either melts as it's falling or it melts earlier. And that in turn allows the ground to absorb more energy, the air becomes warmer. So it's this constant cycle with climate change where the two systems are feeding back into each other. Warmer air temperatures, less snow, warmer air temperatures.
All right, microphone coming on in Mrs. Moore's class. They're joining us from Newmarket. They're a grade 5 class. How are we doing, grade 5s?
What do you have to study in university to do your job right now?
Great question. So the people that I work with have studied a whole big different range of things. I studied geography when I was in university. The thing that I looked at was called geomatics. So understanding how things evolve spatially in time and space. So I did a lot of different things, everything from maths to physics, but also looking at social aspects about how snow can influence people. There's a whole range of topics that are related to climate change that you can study. But for me, I studied geography.
All right, let's take a swing back through our classroom, see if we can do a few follow-up questions. We'll start with Mr. Noble's group and see if you guys have a follow-up question for us.
Okay. All right, Jake, go for it.
Uh-oh.
Okay.
Disconnected again.
Give it Okay, let's try that again. Go for it.
I have a question. When it snows near us, does other places where it does snow, like when the snow goes away with us, does snow come to other places? Like in the summer, we have summer. In other places have winter. When we have winter, they have summer. Like,
So why is it that snow doesn't always fall in the same places around the world?
The weather we have determines where snow falls. It's all part of what we call the energy and water cycle. So you might have a really hot day that evaporates some water in one place. That water is transported in the atmosphere somewhere else where it's a little bit colder, and then it can fall as snow. So all that's really determining whether or not you get snow is how cold the air is and how much water is available in the atmosphere. When you were saying, you know, there's some places that have summer and some places have winter, yeah, for sure. There are places in Australia and New Zealand that get snow, particularly in their mountains. So during the summer, they might get snow there. And then also in Antarctica, they'll get snow in an opposite time to you a lot of the time. Well, they sort of get snow all around the year, but definitely in the case of Australia and New Zealand, they do get snow in the mountains sort of at the opposite time to you.
All right, so I'm going to steal a question from our online community. Mrs. Huxley's grade 5s in Brampton, Ontario are tuning in via YouTube. And Josh, they heard you talking about snow becoming packed. How does the snow become packed?
So as snow falls and it's stacking on top of each other, if you've ever seen a snowflake or drawn a snowflake, you might draw it with big pointy arms. When snow sits on the ground, its tendency is to go back to the shape of a sphere. So it loses all those big pointy pieces. When it does that, it can fit together more tightly. And so as it fits together more and more tightly, it becomes more dense. The snow will then start to sort of shift downwards as it starts to pack together better. So we get a snowpack over time when that happens.
All right, back to Leamington. Your microphone's on if you guys have another question.
Okay, go ahead, Brian. Does some people live where you work?
Can you try that one more time, bud? I just heard the last part.
Do some people live where you work? Yes.
Yep. There definitely are people where I work. In the case of Inuvik, where I've just come back to, it is a town in the Arctic. There are lots of people that live there, that live their whole lives there. There are other places like Alert and Eureka where people don't live year round. Well, there are people that live year round, but only for science purposes in those two places. Eureka is a weather station that we have in the Arctic. So there's 5 or 6 people that live there in shifts of 6 months, but there's no town or city, so you can't go to the store or anything. It's just one set of buildings.
All right. Mrs. Juba's class, your microphone's on again if you guys have another question.
We do. Go on. My name is.
My name is Thomas.
Louder.
My name is Thomas. What is your favorite part of your job?
My favorite part of my job, I really like getting to talk to you. One of the favorite things that I get to do is talk about my science to not only other scientists, but get to talk to people. I really enjoy being able to talk to people about snow, find out what they know about snow, and then also teach them a bit about how it's related to their lives. Because we don't all see snow all the time, a lot of people don't think about it in a good way. So maybe they think, oh, snow's cold, I don't like it, I don't like to shovel it. But if I get to talk to you and tell you a bit about snow, you might realize how important it actually is. So having questions like yours helps me to think about the way I do my science in different ways. And to me, that's really important.
All right, very cool. Mrs. Philpott's class, your microphone is on again.
What happens if you get too cold?
So if you get too cold, a couple things can happen. You may have heard of something called frostbite. So you can actually get a sort of burn from the cold. So to keep from getting frostbite, we have to make sure that all of our skin is covered. So in some of the pictures, you might have seen me or my colleagues wearing face masks, wearing big gloves and everything. That stops us from getting frostbite in a lot of cases. But the other thing is we have to keep moving. So if you're cold and you stand still, you'll get colder a lot faster. If you're ever really cold, you can start running around, your blood starts pumping, and your body helps you to get warmer. Now, there is points that can get dangerous with something called hypothermia, but we have to make sure that we're really prepared when we go in the field. That means having the right equipment, checking on our friends all the time. So every time we're working, we're looking at our colleagues and we're checking to see if they have frostbite or if they're in danger. We make sure as a team that everybody's okay, but if one person gets too cold and they get, say, frostbite, we go home right away to make sure that they're okay.
All right, important to remember those safety protocols or rules, especially when you're somewhere so remote. Mrs. Elliott's class, your microphone is on one more time.
What do you eat on your expeditions?
When we're really far away, we have to make our meals quite simple. So we usually cook with just, say, one pot. We'll have things like pasta or couscous or soups. But we also want to make sure that we're getting in a lot of calories. Because we're working out in the cold, our bodies burn our fat and energy reserves a lot quicker. Now, it might sound silly, but to help with that, we eat a lot of two things. We eat a lot of nuts, which help us get our energy, but we also eat chocolate bars. Chocolate bars for us is a really quick way to get a lot of energy and to stay warm. Now, I wouldn't suggest you do that in your regular lives, but for us, it's an easy, quick way to get some energy.
All right, very cool. And do you find you eat more because, you know, you're working hard, you're expending more energy, keeping warm? You find you eat more calories when you're further north?
It's really hard when you come home because you still have that hunger for a week or two afterwards, but you definitely don't need to be eating that much when you're down here. So when we're up there, you definitely feel the hunger because you're doing a lot of physical work. We're carrying equipment, we're riding on snow machines, but just even standing still in the cold, you're burning a lot more energy because your body has to pump your blood and has to heat yourself for a much longer period.
All right, and we'll make a quick trip to Mrs. Moore's class, see if they have a follow-up question for us.
How do you get your supplies at the research station?
Did you hear him?
I did. We have
Okay.
a couple different ways that we can bring things in. If it's really far away, like in Eureka where there's no roads, there's 3 different ways. There's a ship that comes in each year that will bring in a whole bunch of supplies that are needed for the full year. There's also aircraft that can fly from places in the south and land at the airfield there. And then sometimes helicopters can also go. But what the stations try to do is to make sure they order everything they need for the full year ahead of time so that it can come up on the ship, because that's the most economical way for them to do it.
All right, then let's check in one final time with our class or our group in Switzerland, see if they have one more question.
We do not. My students had to leave.
That's okay. Thanks for hanging out with us today.
Sure.
All right. Well, Josh, before we wrap up today, there's a question that I've been thinking about ever since you started talking about snow. And I was wondering, does snow hold pollutants from the air well? And would you recommend standing outside and catching snowflakes on your tongue in the winter?
Snow can have impurities. So there's things like black carbon that can be held in snow and other pollutants. But I don't know that sticking out your tongue and catching some snowflake is a bad thing. I think it's just a fun thing to do.
Okay, good to know, because that's something I never want to have to stop doing. So good to know it's still in the clear for that now. All right. Well, first of all, boys and girls, thank you so much for hanging out with us today. Great group of classrooms from all over the place. Great questions as always. And then Josh, thank you so much for spending some time with us today, sharing your research. Where would you recommend? I know you shared the website with us. You'll share your slides. But if students wanted to follow you a little more closely, how could they do that?
So I post a lot of pictures and talk a lot on my Twitter. So if you follow @Geomatics, we'll make sure that gets posted out on Twitter so that you can follow me. I like to make sure that I'm telling people what I'm doing. We do a lot of really interesting work, and it's important that we be able to tell people, not only through science papers, what we do, but talk to people, find out what people think about our work as well. So follow me on Twitter. I post a lot of really interesting pictures there, and I hope you'll get a chance to see those.
All right, awesome. And then I'll just point out as well that there's another great website, Environment and Climate Change Canada, called Climate Kids. So if you search that in Google, you'll find it's a newer website, and that's a cool spot. You can check out some more facts about our planet and climate change. Well, Josh, it's always great to steal some of your time. I'm hoping one time in the future we can even get you from the field, maybe send out one of our satellite units with you. I think that would be really cool if we could do that in the future. But thanks so much for hanging out with us today, and definitely getting kids thinking about snow in a different way and just how important it is.
Absolutely. Thank you for having me, and it'd be a pleasure to do this again sometime.
All right, awesome. Well, boys and girls, I'm going to turn your microphones on. If you want to get nice and loud, a big goodbye and thank you for Josh, and then we'll sign off. Here we go. All right, excellent job at that as always. Thanks again, everybody. Thanks again, Josh, and we will see you next time.